Okay. We are live, as it were. And so, I don't know if you know, but if you go, like, do you have the chat open?
No.
I gave you the link to the chat.
Yeah, no, I just forgot to open it.
So click that link.
Yes.
And then down at the bottom right-hand corner, there's 3 little dots, ... right?
Yep.
So click that.
And it gives me a white square with nothing in it. It doesn't work on my end for some reason.
What? So you're looking at the YouTube pop-out chat.
Yeah, here, I'll screen share it with you.
And it says, oh, look, we're live, right?
Yeah,
okay.
yeah.
And in the bottom right-hand corner.
Yeah, I'm going to screen share because you don't believe me.
I sure don't. Your lies will not be tolerated.
Here, let me just screen share my whole desktop so you believe me. After I close
and that bottom right-hand corner, click it. Show what happens.
Okay, let me get it so that you can see everything that's going on. Which means I need to move that window over there. I want to share that screen. Okay, so I come over here. I click on it. I get a white box. That's all I get is a white box.
Okay. All right, then I take it all back. I've never been more wrong. Are you done being right? Okay, well, but I'm going to use the awesome power of that to say hello to Adam Synergy and Brooke Poem and Brooke Mulligetta and Elad Avron and Guido Bibra and Helge Bjorkog and James Gibbs, Jens Cordua, Jim Meeker, John Cross, Michael Thompson, Mike Pyrotech, Nancy Graziano, Renan Casagrande, Sylvan Westby, Stephen Alvey, and Thomas Traniker. Look at me. Ad block. Are you running ad block?
I am.
Aha. Someone is suggesting that, but I don't think that would do it.
No, it shouldn't.
Okay. Look at that. I tried all kinds of crazy names. Kurt Savage. Yeah, you got to chat. And then if you say hi and do in the chat, then I'll see your name in the list of active people, and then I'll say hi to you. So, and if you're just like a silent looky-loo, like the 50 plus people who are there right now, you really should come out of your shell more often. There you go. Hey, Jason Ramos, Nicole Gatnikar. Maybe Pamela needs the YouTube gaming app for live chat. Richard Strassel, BK Renugal. Let me try that. B Krunigal.
And Jim, yeah, it is Chrome for Mac.
Yeah, Mike Mills, Matt Woods, Justin Steger, Matthew Pendlebury, Tom Nathy, Matthew Fontaine. This is awesome. Christian Berndt. Cool. That's awesome. Dennett Benkiki. Ron Mader.
Random unrelated. Boing Boing just announced that the review board is ruling that health insurance must cover robotic exoskeletons. And that is like the most awesome headline I've seen.
We predicted that for years. Pete Brumwell, Murphy Mai, Nichols of the Yard, Andres Munoz. How's that meteorite holding out, Andres? Larry Kennedy, Wayne Francis, Renan Casagrande. I think we got everybody. Okay. So if you have no idea what it is that you have stumbled into, this is going to be an episode of Astronomy Cast on my new super fancy streaming computer. So I have I've got the big Bertha working, and I'm sure it feels exactly the same to you. But it plays Just Cause 3 really well, and that's, I think, what matters most. That's not why I got it. No, it's so I could stream it. It's an i5. Oh, I forget. It's got a 960, 16 gigs of RAM. It's got an i5. I don't know.
Are you sure it's only an i5? Because I'm on an i7.
Yeah, but it's like the super fast i5. Yeah.
It's faster than 3.4 gigahertz?
Yes.
Okay.
It's an i5. Hold on. It's a 6600. I don't know how many gigahertz it has. No, it has 3.3 gigahertz. So
So my older computer is faster at 3.4 gigahertz with an
How
i7
many
core.
cores does it have?
It has 4 cores.
Oh, it's 3.9 gigahertz. Did I say that?
Okay. No, you said 3.3.
Yeah, 3.9. It's
Okay.
got 1 million gigahertz. Okay, let's do this thing that we call Astronomy Cast. Tell me when you're ready.
Someone just posted a very cute picture of a coyote. I'm going to bypass that, and I'm ready to click record.
Stay on target.
There's a cute coyote between me and the
Squirrel!
record button.
Yeah.
Okay, I'm pressing record. Hi, Preston. We'll hopefully get you all the files this time.
I have pressed record as well. This is all very strange to me now. Okay, never mind. I'm sure it's fine. Leonardo dos Santos says I should plug in a video card and I can play Fallout 4. Oh, it's got a video card. It's got a 960 in it. It's very fast. Okay. That's right. We were going to do a show, which we like to call Astronomy Cast. Okay,
Yes.
Here we go. Astronomy Cast, episode 404. What we know, what we don't know, and what we can't know. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos. We help you understand not only what we know, but how we know what we know. We said what we know and don't know and can't know quite a lot. Wow. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing?
I don't know. I probably can't know. No, I know. Doing good. Doing good. The weather is lovely here, and we're, it's that time when we come back around to spring and we notice it.
It is true. I bike rode like 36 miles this weekend, lapping in as much sunlight as I could, but we were only having Indian summer. So while my tulips are coming up, they're going to get snowed on later this week.
Wah, wah. No, we're done with snow. It's gonna be nice from here on out. Okay, cool. So let's do this episode. So there are the things that we know, the things that we don't know, and the things that we can't know. So how do we know which one is which when we're deciding to fund research and direct our scientific inquiry? And this just sounded like a great quote from, and I can't believe I'm saying this, from Donald Rumsfeld. And I'm trying to remember the gist of it, but it was like something like, there's the unknown, there's the known known, there's the known knowns, there are the known unknowns, there are the known so you have the known unknowns, and there's the unknown unknowns, the ones we don't know that we don't know. And although it was used to justify a war, it's actually a really kind of clever thing to sort of categorize the world in, which is that, when we direct our scientific inquiries, there's this stuff that we already know. We know gravity makes things fall. We know, and we know sort of mathematically. And then there's the stuff that we know, but we know that we don't know it. So, and then there's the stuff that we don't know that we don't know. And then there's a whole other class of stuff, which Rumsfeld forgot, which is that we can't know it. And I think that, that was a really good distinction that you put in. So let's kind of go back to the beginning here and sort of talk about, you queued this topic up this week. So what's your philosophy here in approaching this?
Well, we get lots and lots of questions coming in everywhere from Twitter to Facebook, so on and so forth. And some of them are related to things that we can't answer, in which case we answer them or point people at a web link. But
sometimes there's some math.
Sometimes there's some math, and I have more than once recommended people take college courses. But at the same time, there's a whole lot of questions we get where it's like, we don't know that. What do you mean we don't know that? Well, we can't know that. What do you mean we can't know that? Well, there's just some things the universe isn't going to let us know. Now, other times it's like, we don't know right now. We need to build a bigger telescope. And so it seems like there's a lot of difficulty understanding the difference between the things that we're going to know soon. We just need a bigger hammer. The things that we just don't know, could go in any direction. And then the things that people put forward that are absolutely not testable. And we have absolutely no way of knowing whether or not they're real.
Yeah. And so let's sort of come up with some example questions, the kinds of questions that we might get, to which let's go with the we know it category. What's some stuff that we just know the answer to?
Well, stuff we just know the answer to is, what is the distance to Mercury? That was something that took us a long time to figure out, but now we know it very precisely thanks to things like radar. So that was the kind of thing that required the invention of better and better hammers, in this case, better and better optics and technology. So we know the distance to Mercury.
Right. We know how long it takes for Saturn to complete a rotation, which took a long time to figure out. And we're not even entirely sure yet.
It has big error bars.
Yeah, we're pretty close, which is kind of amazing. That's a question that we don't really directly know the answer to. But it took being able to measure the magnetic field of Saturn and calculate how long it comes around, because watching the clouds turn around actually doesn't help you get that really specific numbers, because the thing is changing so quickly. So, it's another thing that we now know.
And there's things like, we now know that galaxies form both bottom up and top down. They form both through the giant collapse of a giant cloud into a giant galaxy, and through a whole bunch of small galaxies forming one by one and combining into bigger and bigger systems. This was something that's only been figured out in the past couple of years. And even in some of our early episodes, we're like, we don't know. And new technology, and this is only going to get better understood as James Webb Space Telescope comes online. So these are all problems that just took better hammers.
We know that quasars are supermassive black holes that are actively feeding. We know that black holes exist, and that there's a supermassive black hole at the heart of the Milky Way. So, obviously there's lots of stuff that's even simpler than that. And we now know that gravitational waves exist, although, we knew them back in the 70s thanks to the indirect observations of pulsars. But we know now, that we have the ability to detect them. So those are things that we know. And I guess there's things that we know, but we know with more and more accuracy, right? So like, we know the age of the universe. Mm-hmm. And we're bringing down those error bars.
The expansion rate of the universe. When I was an undergrad, as I've said before, we were told, just use 100. It's good enough. It makes the math simple. And now we have it to a couple of significant figures.
We know the size of Pluto thanks to the New Horizons spacecraft that did a flyby and was able to finally provide a precise measurement, as opposed to one that had pretty big error bars.
Now, so these are all examples of things that people knew that we'd be able to measure. Once, give or take, Kepler coming along, we didn't know we'd be able to measure the distance to Mercury until Kepler came along. But these are all things that, for the most part, we knew we would find the answer for one day. And finding their answer was part of the justification for building better telescopes, for building more exploratory spacecraft. These kinds of answers are the reason that we build facilities, the reason that we have robots roving our universe for us.
Yeah. It wasn't necessarily one of its specific mission requirements was to measure the size of Pluto, but that's one of the things that New Horizons was able to do. And you couldn't have gotten that level of accuracy without sending a spacecraft that close to the dwarf planet. Okay, so those are the things that we know, and we specifically chose the stuff that have been figured out within the last decades, maybe 100 years.
Right.
So let's talk about the things then that we don't know, but can know.
So we're starting to get a better understanding of what is the size frequency distribution of planets around other stars, which, put another way, is we're figuring out how often we find planets of different sizes around different kinds of stars throughout our universe. And this is getting us step by step closer to being able to build better models of planet formation. Prior to the 1990s, we could tell you nothing about planets in other solar systems other than maybe they're there. But at this point, we're starting to build better and better technology that will get us better and better numbers that Well, will start telling us, where are the other Mercuries? Everyone talks about finding the Earth twin. I want to find the Mercury twin. We're getting there.
That's sad. But
hey, no one shows Mercury any love. I'm going to love the unloved planet.
Right. So I guess, you know, so if you were to like put some rules to this, right, like the stuff that falls into this category, right, it's the stuff that either we just haven't even discovered any of them yet. So it's still an open question on whether or not these things even exist, like intermediate mass black holes, or you know, some, you know, the largest mass of the population, 3 stars, or things like, you know, things that are at the very.
Is it testable? The most straightforward way of looking at it is this a testable concept? Are there intermediate black holes? That we can never prove the negative. That's the problem with negatives. But we can prove the positive. We know what they would look and smell like. Well, we don't know what they'd smell like. We know what they would look like in outer space and how we should be able to detect them. And we just haven't yet. The universe is a kind of big place. If there's an ability to test for a thing, it's knowable, but just not known yet.
Right. Okay. So let's go with some other examples that you think are sort of in the, even with the sort of the capabilities that we have right now, or the observatories that are coming out in the next little while. What are some of those kinds of questions that we don't know today that we should know? You know, check back in 10 years and we probably will know.
So just in our own solar system, Planet 9, is there life on Europa? Is there life on Titan? Why is there this cliff at 55 AUs in the Kuiper Belt population? All of these different things, it's a matter of building a bigger telescope, looking in the right place, having the right timing. There's a chance of solving all of these. Looking beyond our solar system, we're going to start to be able to figure out at what point do planets settle into their orbits? At what point do we see wild collisions still going on? We'll be able to get enough snapshots of solar systems at enough different points in their solar system evolution that we'll start to understand not just the formation, but the evolution, the nice model of other solar systems over time. Looking beyond solar systems, we'll be able to get better and better understandings of how galaxies have formed, how the metallicity distribution in galaxies has changed. With the James Webb Space Telescope going on, there's the potential to start to understand the gas and dust evolution and distribution in galaxies over time better than we can now. And this is all cool stuff. Large-scale structure formation in greater detail. There's a whole lot of filling in the details that comes with identifying the known unknowns that are testable.
Right. And so I think the filling in the details one is great. Is there a Planet 9? Right, that there might be a Planet 9, and it may be just so far away and so dim that it's just outside of our capabilities, and it could take us hundreds of years to find it. But it is testable. You know, you could find the little blip moving at the right rate, and then someone else could point their telescope at it and confirm it, and you could send a spacecraft there and find it. So these are all sort of within that capability. But there's the stuff that and as we said, the stuff where you're really narrowing down the error bars. You know, we'll send another version of WMAP up, and it's gonna or Planck, and it's gonna take the age of the universe down to within tens of millions of years, right? So then let's talk about that stuff that we can't know and why.
Well, and this is where we start to get into things like, what's outside of our universe? Blah. Are we one of many universes? Maybe.
What came before the Big Bang?
Yeah, science just doesn't have any tests that we can do to answer any of these questions. And it's when you get into these untestable ideas. String theory is currently not testable, which is why it's one of those things that makes me grouchy.
But we all know how much you hate string theory. So what? But I mean, I think it's not like there's no hope, because there are ideas to try and say, well, maybe you could test what came before the Big Bang, if you could somehow find some evidence, some echo of what was here before, somehow permeating the universe as we see it today, and that could give you some hint or clue on what came before it. So, I mean, you can have stuff shift categories from we think we can't know it to maybe there's a, if this test turns out, then that might tell us. But
the thing is, a lot of these things are based on if it turns out there's underlying theory that completely invalidates or completely changes our present understanding of the universe that is designed by some genius who doesn't yet exist. It's when the shift to make something from untestable to testable requires rewriting our underlying physics that I start to get, I'm not sure that counts yet. That's the alternate universe, new Einstein required kind of way of looking at things.
Right, but we talked a bit about string theory, right? And so there's this idea that if you could, the earliest moments of the universe, maybe the initial strings could have gotten their scale magnified into the cosmic microwave background, and maybe you could detect it in that, maybe there's a test.
And it's when someone can define a test based on not having to rewrite the physical laws that it makes it much more rational. So when Einstein came along, he didn't require us to rewrite Newton. He required us to expand upon it. And there's a difference between having to rewrite the rules and expand on the existing rules. And if string theory can come up with ways that match everything that we currently observe and says, here's how you test it, it's the here's how you test it part that's still missing, with people going, well, let's see if we can figure out a way to get from this place where string theory is at to this place where the cosmic microwave background is at, and saying we need to define a path between these two islands. Well, it's hard to make a path over ocean if you don't have a boat.
So what is the, we talked about some of these, and there's a million of them, stuff that we don't know and can't know. Another thing that's kind of interesting is that the laws of physics themselves will prevent us from getting to know things. Like there's the uncertainty principle. I actually had a conversation with Lawrence Krauss a few years ago about this, and he said that there could very well be, our physics could take us to a place where we can't probe any further. It's just impossible.
Right. And it's not just with the uncertainty principle. The speed of light is a frustrating limit that you might be able to tunnel from one point to another, but one of those points probably isn't going to be the center of a black hole. And so it's quite possible that we'll never actually understand in a testably proven way what the inside of a black hole is like.
Except with gravitational waves.
Yeah, those still aren't really going to help.
Right. And then the other part is that there's stuff, and you sort of hinted at this, there's stuff that is beyond our vision. It's there. If we could get there, we could test it, but we can't get there. The laws of physics absolutely prevent it. Something that's outside of the Hubble sphere of us here. There's stuff there, most likely.
And we may never actually know if we live in a finite or infinite universe.
There's a great example, right? So we may not be able to know, which is crazy, right?
See, I find it kind of awesome.
Really?
You get frustrated, and I'm like,
I want to know.
No, it's cool.
Yeah.
We study to the limits of what we can understand, and there's so much left. Why get frustrated when you haven't figured out all the stuff you can figure out, that there's stuff that you can't figure out?
And then I think of the sort of that last category, the one that we talked about, the Rumsfeldian unknowns, right? That's where I think the source of the most interesting scientific inquiry comes from. It's that Isaac Asimov, quote that the most interesting thing is not Eureka, but that's funny. Right?
And this is where things like the LSST have so many people excited, because this is an open-ended instrument. There's some instruments, like I was grouchy last week about LIGO, that only solve one problem. But LSST, it's out there with the primary mission of making sure we don't die by rock. But as it's out there discovering all these asteroids that are part of its primary mission, it's also going to be turning up potentially tens of thousands of things that flicker, flare, and move in the night, and helping us, well, know about things that are so low probability that we've just never seen them before, helping us notice things that you have to have systematic observations with that kind of cadence. It's going to point out things that we can't even speculate on. And it's the fact that we can't even speculate that is so cool, because we know we haven't watched the entirety of a stellar lifetime. And it's going to allow us to see so many stars at once with sufficient detail that we're going to fill in all of those details of a star's life.
And the classic example of this surprise was things like dark energy, where scientists were looking for one outcome and a completely surprising one came about. And it told us something about the universe that we had no idea. In fact, it's like before 1998, we didn't know that 76% or whatever it is of the universe, we didn't even realize that was part of the equation. And then suddenly you now have to ask yourself, what is that dark energy?
So this is actually even worse than that. We had an equation that had the lambda term, the term that we now use to express dark energy. And we made the choice to get rid of that term and say, well, we see the universe is expanding. Clearly, lambda doesn't have a value that stops the expansion of the universe. Maybe it has a value, but that makes the math a whole lot harder. So let's not do that.
Yeah.
And so, like, all of the test cases in cosmology books and everything were we assume lambda equals 0. And no, lambda doesn't equal 0. And to quote Chris Impey in one of my favorite moments of a talk ever, who ordered this? Yeah,
that was most unexpected. But as we go back to some of these missions, right? You look at the mission from New Horizons to Pluto, and we had lots of conversations with the mission scientists leading up to this, and I kept asking them this question, right? It was like, really, come on, just between you and me, right? Like, you're looking for the stuff that you weren't even expecting, that you weren't even planning was going to happen. And of course, that's what they really want to see. They want, of course, we'd like to measure the magnetic field, and we want to know what the atmosphere does. But hey, what a surprise. Charon and Pluto have vastly different terrains. Charon has this enormous chasm on it. Pluto has this incredibly young surface with glaciers of mountains made of ice, and this glaciers of ammonia, like stuff they never would have expected.
And this is part of what's so awesome about building versatile instrumentation. SDSS is another one of those. We're just going to capture all the light and then see what we discover. You have the science is going to happen. They knew they had a lot of science that would happen with certainty with Pluto. But then you build the instruments flexible enough that when you realize, wow, okay, the universe is more awesome than the human mind could ever imagine, which is what we keep rediscovering because we can't remember it for some reason. Until we can consistently remember the universe is more awesome than we can imagine, we need to just keep building flexible instruments that serve many science purposes. And luckily that keeps us safe when it turns out we need to do things that we hadn't anticipated.
So let's talk about policy for a second then, which is that if you had your way and we could direct science funding more, I guess, away from the cogitating over the stuff that maybe we can't even know, where would you put the funding?
Oh, man.
Throwing a softball.
Yeah, it's not a softball. And I don't want to get hate mail. So I think there's a lot to be said for things that aren't necessarily kitchen sink instruments. You have to have a certain amount of specificity, but having really good high-resolution spectrographs that are capable of, for brighter objects, giving us really detailed understanding of what is the chemistry out there so we can confine our models. Having some really good high-resolution imagers that allow us to start to get at fine structures. But then also have the stuff that just collects as much light as possible and throws it into a lower resolution setup so we can see what's at the beginning of the universe. At the end of the day, what you need is big glass, big collecting area. It's not always glass. Radio needs other things.
Yeah, X-rays, whatever.
Yeah, attached to both a really good high-resolution set of instrumentation for the nearby universe and a really good low-resolution set for the most distant part of the universe.
I mean, if I could sort of make this almost an analogy, it's about listening to the universe as it is. It's about listening to nature and letting nature tell us how it functions and how it operates. And you need to build your theories, but the number of times, like maybe the Higgs boson, I mean, I can't think of a lot of times where somebody, neutrinos, where you worked out the math in advance for a particle that you thought might be there, or an object that you might think was going to be there, and then 10, 20, 30 years later, the thing came about. It's a lot more about building those tools, getting them out there, collecting and listening, being a really good listener, and then turning around and going, well, what's in here that's weird, and let's try and figure that out.
And this comes down in a lot of ways to the Simon White Rocky Kolb debate between high cost, highly flexible instrumentation, the Hubbles of the universe.
Yeah.
And the highly focused, highly specialized instrumentation, Large Hadron Collider, WMAP, Planck. And there are times when you need the Large Hadron Collider to find your Higgs and figure out if supersymmetry is another Nobel Prize for Weinberg or not. But at the same time, I'm a huge fan of the ideals behind the Great Observatory Program. This was the program that gave us Hubble Space Telescope, Chandra, Fermi. I think Spitzer was one of the great observatories. Just took us all the way through the electromagnetic spectrum where you should focus in space. I mean, we didn't launch radio telescopes, but gave us that full access to the universe. Having that full access to the universe allows us to be nimble in the face of new science.
Well, I think though the Large Hadron Collider, fits more as a generic tool. I mean, it's a really powerful particle accelerator collider, and all of the particle discoveries have come out of more and more powerful particle accelerators. So I think there's value. I wouldn't see it as a single-purpose tool.
So it's very locked in on what it can collide and what energies it can access. So there's a lot of work that it's not slamming together atoms. It's not looking at a lot of the higher mass regime where you see things happening in the National Superconducting Supercollider or National Superconducting Laboratory, rather, at Michigan State University. We still have Fermilab. We still have various other laboratories that are building heavier elements. Unfortunately, colliders, there are some that are tuned really well for creating heavier and heavier elements. There are some that are tuned really, really well for making medical isotopes. And there are some that are designed for making discoveries at different energies. And LHC has a very narrow window on what it's able to do. And this is why we have this whole suite of places that make atoms and molecules and particles go boom.
Yeah. And I think that a lot of people make philosophical questions. I mean, they try to make that a scientific question. And that comes up quite a lot. I mean, you should read the comments on the YouTube chat and the YouTube channel of mine, right? Like, I ask like what came before the Big Bang or things like that. And that's the gist. It's like, this is a question that we can't know. And yet philosophy is what people turn to with certainty, which is, which is not appropriate, I think.
Yeah, it's the quote from our town that I may screw up slightly. Truth is only known by the poets, the drunks, and the mad.
That's awesome. All right, on that note, thanks, Pamela.
Thank you.
Which one are we? Okay. Thanks. We'll talk to you next week.
Okay, bye-bye.
Oh, I saved it as.
Did you do bad?
I gotta split it to mono.
Okay.
And now it's fixed.
Okay, that was
all hail Audacity. If you did it too, it's super easy to fix it. Give us a second, everybody, and then we will.
Yeah, sorry. This is the staring blankly at our computers part of the show.
Remember that time when I installed Dropbox on this? Okay. I wonder if it can handle posting to Dropbox.
That is a bandwidth issue, not a computer issue. So you have the same internet you had before.
I think it can handle it.
You do not apply logic in places sometimes.
I have a lot of both. I have a lot of computer and a lot of bandwidth. Both of them.
You have the same bandwidth you had with your old computer.
Yeah, but it could be better. All right, I understand it.
Except now you're bit stopping and pixelating.
Fine, I'll pause it. Pause.
I hope we're amusing all of you.
Okay. Let's see. Ilad Avron says, what do you think has been the most surprising discovery in terms of we thought we could never know this and then suddenly we did?
Say that again.
What has been the surprising discovery in terms of we thought we could never know this and then suddenly we did? Higgs boson is I think a good example.
No, we knew that we would know that one.
Did we?
Yeah.
We were certain that we would find the Higgs boson?
Or not find it and know it didn't exist.
Yeah.
It was kind of, they were either going to find it or we'd wasted a whole lot of billions.
Yeah. People are suggesting gravitational waves in the chat. But we knew the gravitational waves were there. I mean, Einstein predicted it. Somebody's about to get banned.
Yeah, please ban that person. No politics here.
Watch. There's a lot of moderators. Don't worry. I'm sure they're falling all over themselves. Okay. Let's see. What else? Jim Meeker just noted that we're receiving signals from the U2 rover again, which is really cool. That's the Chinese rover.
Thank you. That's cool. Yeah, people underestimate the Chinese space program, and they're doing good stuff.
Wayne Francis asks, define infinitely small and how that applies to the universe. What does infinitely small mean? Very, very small, the opposite of infinitely big.
So the problem with using the word infinity is you can have infinities with infinities, and it just sort of becomes turtles all the way down.
I mean, one of the sort of misunderstandings about this idea of the Planck length is that it is it's like it's the resolution of the universe, but it's not. It's just an interesting cross between two methods of measuring that happen to come at that size.
Yeah.
But it in no way indicates that the universe is that. You can't have
limited.
objects. Yeah, you can easily have objects that are smaller than the Planck length. And Planck himself, I'm sure, would be fine with that, right?
I'm not going to speak for Planck, but
I am. I've heard it from Planck that he's cool with it. So
you have lived a long time.
Yeah, really. But yeah, I forget the exact definition of the Planck length, but it's literally just like when. I forget what
it's a unit cancellation kind of thing.
Yeah, it's when you get this equation crossing into that equation, then the size that you're looking at is like a 1 to the minus, I forget,
47.
47, yeah, teeny tiny, but it is not. You could be smaller than that, right? And so the question is like, does a black hole compress forever? Does it go below the Planck length?
Yeah,
maybe, right? Maybe not. We don't know. But it is a good question, right? Is there a smallest size that's possible? And so we may, there is an answer, but we may not ever be able to know it.
Right. So Michael Thompson is asking a question I can answer. Did we know of the 2 black holes that merged prior to LIGO? Nope. Brooke Mulugeta asks, what about antimatter? The ability to keep antimatter undestructed in a universe dominated with matter. Was that something scientists thought wasn't possible? We actually knew that one would be possible because there's antimatter all around us. Antimatter is only destructive in certain combinations. So you currently have antimatter neutrinos passing through your body, and your body could care less. Positrons are something that exist on a regular basis. So the trick was figuring out how to just keep them isolated, and that was a technological problem of getting vacuums that were good enough.
David Joseph Wesley says, can we know for certain that Mars and Earth will go to war like in The Expanse? Yeah, it's inevitable. Elon Musk will go to war. Man, The Expanse was so good. Have you seen that yet?
No.
Oh, so good.
I also haven't
so
seen
excited.
Deadpool. That one has a higher priority right now.
Well, if I had to pick one, I would watch The Expanse over Deadpool. If I had to, if I could only watch one of those. But fortunately, you get to watch both.
Yeah.
Matt Wood says, spending my first few hours of being 30 watching Astronomy Cast live as a web developer, I must stress my disappointment that episode 404 wasn't about errors in space. He's right.
Man, I should totally have.
I know. We really screwed this up. Yeah. What if we deleted this episode and then next week we do 404 and we never talk about this episode, and then we just do it again? No, I'm just kidding. Don't you take me seriously, because that's madness. Michael Jobin asks, does the spin of a black hole keep it from collapsing? Good question.
No, unrelated things.
But it does potentially make it flatten out.
Right.
But it can't actually expand outside of the event horizon.
Yeah.
So theoretically there's a blobby thing in there that's flattening out
we can't say anything about it. We know its event horizon is flattened out.
Oh, okay, not the singularity itself,
right.
The event horizon, right. Yeah. But it can never flatten down to the point that it could reveal a singularity.
As far as we know.
Right. David Joseph Wesley asks, what level of certainty is needed to make a theory breakthrough and become part of our scientific conversations? So what's necessary?
It depends on what you're trying to prove. I think it was Carl Sagan who said that outrageous claims need amazing measurements or something like that. I can't remember the exact quote.
Yeah, I forget that quote.
So for instance, the Tevatron at Fermilab had several detections that we thought might kind of sort of look like the Higgs. And if it wasn't for such an important discovery being made, I think people would have been willing to say, hey, look, we think we found something. But because it was such an important result when we first discover life, that's another thing that's going to require a whole lot of very careful statistical analysis. But when it comes to things like, this looks like a variable star, we don't require a whole lot of sigma on it, a whole lot of high quality. So if we misclassify something as a variable, we'll fix it later. It's cool to know so that you can follow up appropriately. All depends on what you're measuring.
Yeah. Allow me to go on a rant here. I'm going to go back to talk about The Expanse for a second. So the reason I love The Expanse so much is that someone took a high quality science fiction story that someone had thought through the plot all the way through, made sure it was consistent, had really cool characters, had really cool scenes. They then battle tested it with, readers, and the readers really loved the book series and couldn't wait for the next one. It's the same thing with Game of Thrones. It's the same thing with The Walking Dead. We're at this time where people are taking really great science fiction, fantasy, but just any kind of story, and turning it into a some kind of media thing, but doing it with love and doing it with time, you know, taking the time and not just kind of going, you love Spider-Man, so here's a Spider-Man movie, you know, and all you Spider-Man idiots are going to come and watch this movie, and, you know, we're going to take your money, right? So that is what I think is really wonderful, and I think that we're at this time. Like, I'll take an Expanse. I know people are going to freak out when I say this. I would take the Expanse over Star Wars, the new Star Wars movie, right? If I could head to, again, Deadpool, Star Wars, Expanse, I'll take the Expanse, because it's a brand new story that we just haven't experienced. It's got all of the elements. It's got all the pieces. I loved it. And I want more of that. And so I'm really excited, right? That Tom Nathy just pointed out the same for The Martian. Exactly, right? You've got these great stories that are out there, and now let's adapt them into television shows and movies. This is so exciting that they're being successful, that people are making money doing it, right? You know, when you read Game of Thrones, did you read Game of Thrones before you saw the? Yeah, so you knew that if someone actually did a good job of turning this into a book series, it would have been awesome. So
yeah, and it also means that when they do things that they clearly did just to shock the viewers, it makes me angry. And there was a whole lot of that with Game of Thrones, where they took something that could have been beautiful and they made it horrific, where they added stuff that didn't add to the story. Yeah,
but I mean, and that's what happens when you adapt one media, book, whatever, to another kind of media, right? Have you seen the Dark Knight Returns cartoon on Netflix? It's a full recreation of the original Frank Miller comic book, and it's awesome.
Oh, that's awesome.
Yeah. Guido Bieber finally read The Martian. He said, you were all right. Absolutely awesome. Like the book. Yeah. And don't forget, we interviewed Andy Weir on the Weekly Space Hangout. So go back around and watch it. The Martian or The Expanse. Oh no, Nancy Graziano I'd take The Martian for sure.
And Noel Rubenthal got the correct quote. It was Carl Sagan said, now it's scrolled.
Extraordinary claims require extraordinary evidence.
And it was Tom Nathy who got it. It was Noel Rubenthal responded, and ordinary claims require ordinary evidence. Which is, I think, a more eloquent way of saying what I was trying to say.
William Van de Beek says that The Expanse is based on an MMO, EVE Online, which well, you know, if what it is that you play the game and somebody shows up out of nowhere and kills you and takes all your stuff, that's definitely, you know, there's a real sort of connection between those two media properties, because that's my experience playing EVE Online is just, I just get beaten up again and again. Wherever I stick my neck out anywhere, someone chops it off. So anyway, I'm going to go back to Europa Universalis. Oh, here we go. Matt Woods will take Deadpool over The Martian, over The Expanse, over Star Wars. Yeah. You know, Star Wars, like, don't get me wrong. I was 1977, I was a 6-year-old kid watching Star Wars. It blew my mind. I could not believe it. But the new Star Wars just didn't capture the same level of excitement and imagination. My kids didn't even want to go.
Really?
Yeah, I was like, hey, anyone want to go see Star Wars? And they're like, nah, I'm going to watch YouTube. And they, you know, watched their Jacksepticeye live stream on YouTube. So no, this is the world we live in. But now I feel like we are reborn. I would way rather have that budget go to more of these kinds of properties. I can't wait for this stuff to keep going. And some of our friends, you know, some of our great sci-fi writer friends, Scott Sigler going to get a movie deal.
And American Gods is getting a television series, and Neil Gaiman has drawn lines in the sand over making sure that people get cast realistically.
Hold on, I got to go back. Okay, Andres Munoz wants to know if Cosmic Quest is going to be at the 2016 Spring Symposium.
I don't know which Spring Symposium. There's so many Spring Symposiums. You need to send me a link. I don't think we're planning to go to any Spring Symposiums, but it's not too late to change our plans.
Hewlett Everett says Fraser's really wrong, but he's wrong on Star Wars. Am I? Am I really? Go back and watch it again.
I think you need to have a more so the thing with Star Wars was it was totally nuanced. There were so many callbacks and innuendos and or innuendos is the wrong word. So many
saying the same thing that
nuances.
have been said many times before. No, you know
No.
what? We got to change the subject. I am just
Okay.
gonna drive people crazy here. Are we gonna do a hangout again? Hangout-a-thon again this spring? Asks David.
Yes, I need to set the dates for it. I still have so many people I need to hire. I'm gonna die. So we really need volunteers to help me until I get more staff hired. So there will be one. It will be in April. I don't have the exact dates. Working on it. Yeah, help. I'm sorry.
Yes. Yes, but it's going to be such a low stress.
It's
giving
going to be
back
all
to
about
the
supporting our
fans.
partners.
Yeah, like let's do some science and don't worry about CosmoQuest. We got the funding. We're good.
Yeah. So
In fact, you know, it's going to be us. It's going to be us trying to find workers.
it could be at this
Yeah.
point.
Yeah.
So if anyone knows a data science person or a someone who just got their PhD in astronomy, just got their PhD in planetary science and likes working with big data, I have a postdoc position open. We're about to have a postdoc in astronomy and a postdoc in planetary and earth science posted through Planetary Science Institute. And we're going to have some other positions as well. We're still working on the details. The state of Illinois has more policies than I thought imaginable. Like the state of Illinois is more complicated than the US government. So yeah, if anyone has some extra energy to volunteer to help me out with social media and other communications and organizational tasks, and Susie, I will be reaching out to you and you too, Nancy. Yeah.
We got some friends who who can help. Come on, let's have some more questions. This is fun. I'm having fun. Let's see. William Vanderbeek. Oh no, I'm not going to say it. You know what? David Joseph Wesley says, "Are you guys Firefly Soundtracks? But the game is on hiatus."
Oh, that's mean.
Yeah.
I hate when you have to create things and then they get put on hiatus. I narrated an entire book and then the movie rights got bought and now the movie's not being made and the audiobook like went into oblivion. This is like the most painful, let me take your creative energy and just throw it out.
The trick is to be a complete and total control freak over everything that you're a part of so that nobody can ever take it away from you.
Yeah, some of us don't have the energy for that, Fraser. You are a superhero.
That is my both my gift and that's my strength and my weakness is that no one can ever take anything away from me because I own it all. But at the same time, I have to like do things. It's nice when people write. So Jacko Van Schaik asks, what about the virtual star parties, Fraser? Is that still a thing? So sort of. There's a thing called the Global Star Party. And if you do a search for that, you should be able to find it. And it is like a ragtag group of people from the virtual star party who have taken it upon themselves, and they just run these things twice a week, I think. And I will be jumping in and joining them, but I'm not the person who organizes them because that burned me out. It was so hard to try and organize, all of the telescope operators with all of the weather. And it was just like week after week, we're like, oh, we don't have a live view tonight. I'm sorry. We have to cancel it. And it was really rough. So the fact that these people are doing it and they've invited me to just come hang out, I support that with 1,000%. It has my personal certification as, approved, authorized. They are the authorized virtual star party. They can use the term if they want. I love it. Do you hear that, guys? Yeah, use the term. Use the virtual star party. You have my permission. You have my enthusiastic support. Matt Wood says, what about doing an episode 500 about errors? Error 500 is the most annoying error, as the problem could be anything.
I can totally get behind that one.
Yeah. Done.
I now like want to look up what all the HTML codes are, error codes are, and like start plotting our episodes around them now that we're into the numbers where that's a thing. And this is where Fraser ignores me for good reason.
Okay, so, no, sorry, no, yeah, there's some ones you get like you get a 403 error and a 408 error, and they mean things. No Rubenthal asks or says in Kerbal Space Program you can move between apogee and perigee without exceeding escape velocity. Aside from time dilation, is there any reason why this cannot be done across the event horizon of a black hole? Once you're across the event horizon of the black hole, all pathways, there is no apogee.
Yeah.
All pathways are into the black hole or into the singularity. So that's, you have to be going faster than the speed of light to be able to get out.
I can't read the comment thread.
No? For a Cain about being a
Jason
teapot?
just broke me.
Yeah.
Thank you, Jason.
443 should be about security. 500 internal space error. 404 moon not found. Rift Track did Starship Troopers. You know what?
Oh, wow.
Watching us do this show but not being able to see the chat has probably got to be almost incomprehensible.
As close as Rift Track, yes.
We've got to somehow get the chat.
This is why we edit it down.
Yeah, well, we don't edit this part. We've got to get the Larry Kennedy. We should start a petition to get James Cameron to remake Starship Troopers. So interesting story. James Cameron now lives in my city. He bought a vineyard here in Courtenay, British Columbia, and I keep trying to think of ways to meet up with him.
Now, does he actually live there, or does he just grow grapes there?
I think he spends some time here. Place is paradise. Why wouldn't he? He's Canadian, and all people who come from the east in Canada, they always, when they make it out west, they never go back. Christian Barron asks, what about your plans on streaming some KSP, Fraser? Yeah, so I've been talking to Amy Shearer Title about doing this, and I've also reached out to Scott Manley, so we might do something. I hope we can put this together. I'd love to. I did one stream. If you go to my Twitch, my son and I did one Kerbal Space Program. Let's see. David Joseph Wesley asks, I just picked up some astro binoculars. What are your favorite celestial targets?
This time of year, you have the whole, like all around Orion.
Yeah, Orion Nebula.
This is my favorite time of year because
Pleiades.
Well, so what's awesome, and I have an entire blog post on Starstrider about this, is if you go to the Orion Nebula in the Sword, it's stars that are in the process of forming. If you go to the Pleiades, it's a fully formed open cluster. If you go to the Hyades cluster, which surrounds the eye of Taurus, the bull, that is an open cluster that is just falling apart to the point that we can barely perceive that it's still there. So you can see the exact same structure at 3 radically different ages. And I just think that's super cool and nerd out about it way too much.
Jeffrey Huang says Andromeda. He also says gay.
Yeah.
Turns out your name, some people like to giggle about that.
Yeah.
Tom Matthews suggests the coat hanger. What I would do if I were you, see my Night Watch there, right there, get a copy of Night Watch, and then just try each one of them, right? Like you look at learn each constellation. And the great thing about binoculars is that if it's in that area, you're going to see a fuzzy, hazy bit, or even, the coat hanger is a great example of something that's like, it looks like a little coat hanger. It's adorable, right? So just spend the time out there learning those constellations and looking at the objects that are in something like Night Watch, and then see if you can see the object actually there.
Yeah, since we're hiring so many people, I'm having to clean out my office, which is really a sucky thing. But it's so we can fit more people in there. And Night Watch is like one of the very limited number of books that got to survive the cross on what's getting kept.
I bought Night Watch when I was like 15 years old, and that's what I learned on. Jim Beaker says, no one mentioned the rosette. You can't see
Yeah,
the
it's not a
rosette.
binocular object in most places.
Yeah, it's big enough it could be, but you need long duration and you need a hydrogen alpha filter, so you just can't see it. Larry Kennedy wants to know how I like my binoculars. Right there. I love them. They are so great. I was out last summer. I was out with my wife teaching her a lot of the objects, and she got really good at it. It was great. We're like, oh, there's there's M13 in Hercules. She learned how to find a bunch of clusters and Andromeda, and it was great. We had a great time. I highly recommend it. The Celestron, the 15 by 75s. They're wonderful binoculars. Doug Joseph wants to know, how old are you guys?
We're babies.
I'm 44.
I'm 40. I don't remember. 43. No, 42. I'm 42. I'm the answer that's the life, the universe, and everything. I was born December 1973. I have no clue how old I am.
Elad Avron says, I don't have good enough skies. Oh, come on. Like, I have terrible skies.
You can see Jupiter.
On the west coast.
You can join Phil Plait in being afraid of Jupiter.
He's afraid of Jupiter?
Look at his tweet from earlier today. It's kind of funny.
Okay. All right. Cool. Well, we've reached the end of this hour. I think it's time for us to wrap that up. Doug Joseph says, let me rephrase that. How young are you? Yeah, that's how young we are. We were so much younger when we started this show.
We were. It's been
almost a decade
lot
ago.
Of years. Yeah.
Yeah. Susie says 42 is the best age ever. I've been there for 3 years now. Awesome. Okay, cool. Well, thanks everyone. I want to sort of remind people that if you want to watch Astronomy Cast and watch us do this live, the best thing to do is go to YouTube, subscribe to the Astronomy Cast channel, and then in there, futz around with the settings until you get it to like yell at your phone when we do a live show and make events go into your calendar. I'm not really sure how to do it, but I know that it's possible. So if you want to never miss an episode, that is the best way to do it. But we do it Mondays at noon, and we try to get the word out as best we can. And we really appreciate all of you. Chatting away. It's wonderful to see the conversation going on. So thanks everyone for joining us, and thanks Pamela.
My pleasure. Thanks all for joining us.
And we'll see you all next week.